So next thing we move into is what's called rational equations. So remember, solving equations, we're trying to find the value of x that makes the equation true. But with rational equations, remember, if there's a variable in the denominator, there's one thing we cannot have, and that's a zero in the denominator of a fraction, because that will not give us an answer, because that's going to be what we call undefined. So one thing we have to do in solving rational equations is find what we refer to as excluded values. So the excluded values is what makes the denominator equal to zero. So what we can do is set each denominator equal to zero and solve for the variable. Now, if the denominator does not have a variable in it, you don't have to worry about it. So that's going to be what we call our excluded value. So if we look at A, notice how the x is in the denominator, so it cannot equal zero. So we set x equal to zero, solve for x. Well, that's why I solve for x. So x equals zero becomes an excluded value. Okay, so we cannot use it. If we solve the problem for x and we get zero as a solution, we have to exclude it and throw it out. So if I look at B, notice how we have x in two different denominators. So we set that x equal to zero, and we also set x minus 3 equal to zero. We solve each one of those for x equals 3. So those are going to be our excluded values. We have to exclude 0 and 3. So if when we do solve these equations, if we get 0 or 3 as an answer, we would have to throw that out and not use it. So look at C. Notice how we have this x plus 2. We want to set that equal to 0. We want to set x plus 2 equal to 0. We don't have to set 4 equal to 0 because 4 will never be 0. 4 is a constant. But remember, a variable can change. So what can you add to a 2 and get 0? Well, that would be a negative. That would create the denominator being 0. What can you subtract 2 from to get 0? That would be x equals 2. So we would have to exclude those two values in that rational equation. So in D, notice how we have just two denominators. X plus 2 is equal to 0. So that would be x equals -2. And then we also have 2x is equal to 0. If I divide both sides by 2, that's going to end up being 0 as well. So that would be the two excluded values, -2 and 0. So as we move forward with rational equations, that's one of the things we have to do at the very beginning is watch out for excluded values. So as we move into solving rational equations, we want to determine excluded values. Again, to do that, our next step is to solve rational equations. We actually can get rid of fractions by multiplying each side by the least common denominator, or what's called the least common multiple. And then it becomes an equation that we're more familiar with, and we can solve for x using strategies that we may be more familiar with. And again, once we solve it, we have to eliminate any excluded values as solutions. It's not a bad idea to check solutions. A lot of times this last step is kind of omitted. So if I want to solve this rational equation for y, the first thing is the excluded values. Notice that the variable is in the denominator, so I would set y equal to 0. That's going to be an excluded value. My next step is identify the least common denominator of the bottom. Well, notice that there's just two different factors, a 3 and a y. So 3 and y becomes my LCD. So what we end up doing is we end up multiplying each side by the LCD to get rid of fractions. So when I write my problem, it's going to be 3y, and then I'm going to have 2 over y plus then 1 over 3, and that's going to equal then, and I have to multiply each side by that 3y. So it's going to be 3y times 1 on the other side. So to clean this math up, notice that the reason I multiplied by 3y is to divide out fractions. So notice how this y and this y would cancel. And that's going to leave me 3 times 2, which is going to give me the 6. Notice that this 3 here is going to cancel with the 3 over here. It's going to cancel with the 3 over here. and that's going to lead me to bring the y times the 1. The y times the 1 would just give me a y. So it's going to be 6 plus y now. So again, if you can do that math mentally, is the best way to do it. And then on the right-hand side, we have 3y times 1. That's going to be 3y. So again, to solve for y, we have to get the y on the same side of the equation. So I can subtract a y here as long as I subtract a y over there. That's going to give me 6 equals, try that again. Switch over, didn't happen. So it's going to give me 6 equals 2y. If I divide both sides by 2, we end up with y equals 3. So since we didn't get 0, that should be our solution. So if I double check myself, 2/3 plus 1/3 does equal 3/3, which does equal 1. So that does check out. So that is our solution to that problem. So if we look at part B, what are my excluded values? That's what's going to make the denominator equal to 1. So notice how you should see y equals 2, y equals -1. That should be my 2 excluded values. The next thing is, I'm going to go ahead and rewrite the whole problem over 2 over y minus 2 times y plus 1 equals 4 over y plus 1. Now, since this is a proportion, we actually can cross multiply to solve this. Since we just have a fraction equal to a fraction, the easiest way to approach this is actually just cross multiply, because remember, with proportions, cross products must also be equal. So that's going to be the strategy I'm going to impose here. So that's going to be 4y minus 8 equals 2y plus 2 when I cross multiply. Again, when you cross multiply, you have to use the distributive property. So then we want to subtract the 2y here, subtract the 2y over here to keep the equation balanced and get the variable on the same side. So that's going to give me 2y minus 8 equals 2. If I then add an 8 to both sides, we can start solving and getting y by itself. So that's going to give me a 2y equals 10. Then if I divide both sides by 5, y would equal 5. Notice again, we have to exclude it if it was a 2 or a -1. And since we got a 5, it should work out just fine. If I want to double check myself, that would be 2 over 5 minus 2 would be 3. That would be 2/3. And on the other side, I would have 4 over, and 5 plus 1 would be 6. And if you notice, if you cross multiply, those fractions are equal because they both give you 12. So that does check out as a true answer. So C, we have 5 over x minus 2 minus 3 over x minus 2 equals -1 over x minus 2. Notice that we already have a common denominator, which is 2. So we also can pick up on the excluded value as well. So the excluded value is going to be x equals 2. That's what's going to make the denominator equal to 0. So what I can do, since we have a common denominator, is go ahead and add the -1. Go ahead and add this 1 over x minus 2 to both sides of the equation, since we already have a common denominator there. So this becomes then 5 over x minus 2. This should be a 3x there. Sorry about that. 5 over x minus 2 minus 3x over x minus 2 equals, plus 1 over x minus 2 is equal to 0. So looking at the top, this is going to give me like -3x plus 6 over x minus 2 is equal to 0. And I can make 0, 0 over 1. So again, to solve this, I can cross multiply. This is going to give me -3x plus 6 is equal to 0. Because when you multiply 1 times -3x plus 6, you're still going to get -3x plus 6. And when you multiply by 0, the answer is always 0. So then if I subtract 6 on both sides, subtract 6 over here, we end up with negative 3x equals negative 6. If I divide both sides by negative 3, I end up with x equals 2. And notice that our exclusion was 2, so we have to throw that out. So what happens is we don't have a value for x, so this becomes then a no solution. We can't solve this problem. So there's no real number that's going to work for this problem. So lastly, let's see if we can put together a word problem.